this is our RC2 section. This is now we're going into describing and graphing linear equations, inequalities, and some systems. All right. So on here, some keywords we need to look at and know. Anytime I see the word rate of change, that's the same thing as the slope. Now, we have a formula. This formula here is on your formula chart. Okay, gotta remember to place in the values correctly. Your y2 minus your y1, and also x over x2 minus x1. The other part is if you're given a graph, you want to choose, this is very important, choose any 2 points. You can create a table, but basically you want to go back, once you get your 2 points, you want to go back to this formula. Okay, so I'm going to do an example of each, and then I'm also going to kind of talk about some calculator tricks to help you with that, because I want to say, yeah, this one's underneath here. So rate of change for the graph below. So on this one, this is f of 7 equals 1. So when it's in function notation, that f of x, okay, let me oops, sorry. Let me undo this, what I was writing. Function notation, and we had it on the other page, is x comma f of x, okay? And I can show you on the other page when we did function notation. Look before the page here. Yeah, right here, x comma f of x. And we have to remember your f of x is the same as your y, okay? So what we're gonna do, let me go to that, back to where we are. We're gonna write this as an order pair, because what's inside the parentheses is the x, and what's outside what it equals here is y. So this is an order pair, 7 comma 1 and 4 comma negative 1. So then I can use the formula y2 minus y1 over x2. So just remember, and I probably should have stacked it differently, so which I will do right now. Normally we show these, come on, side by side, like such. Yeah, there we go. We can have the first order pair is x1 and y1, and the second order pair is x2, y2. So we're just plugging into the formula. This would be negative 1 minus 1 over 4 minus 7, and we can simplify. Now we can go into our fraction box to just get the setup. So I could go second, click, get the blank screen, the fraction alpha x. We have negative 1 minus 1, and then we had the alpha x arrow down. We had 4, was it 4 minus 1? 4 minus 7, sorry. 4 minus 7. And we can just type it in there, hit enter, and there is our simplified answer. Okay. So you want to always look at points. This is 2/3. All right, to get your rate of change. So if they give you a table of x and f of x, remember your f of x is the same as y. You want to pick 2 points. You can do the first 2 points. You can do the first and the last point. It doesn't matter. It's all going to come out the same, but you got to use your formula to do that. Now we will talk about how you could possibly do a list. Let's just practice setting up the formula. The y's come first. So if I do first and last, this would be 2 minus negative 2 over 1 minus negative 3. And then we're typing that in our calculator. Make sure I had that right. 2 minus a negative 2 and 1 minus a negative 3. And then we're going to hit enter, and then it reduces to 1. Okay, so I always just use the slope formula. That is the best way. Now, if you have a graph, this is where choose any 2 points. So we want to use exact points. So for me, since I'm using the graph, I could use 1 doesn't really come out here. 2 is an exact point. This is 2 comma, that's 10, and that's 14, so that's 12. In between is the increments of 2, yeah. So there's 2 comma 12, and then I need another exact point. I could go to 3, but that's not exactly hitting the point. I can go back to 4 right here. That's 4 comma 6. And now I'm going back to doing the formula to come up with the slope. Now, I know some of you want to count the rise over run, but I would do this because you got to watch out for your scale. See, this is an increment of ones, but this is an increment of 2. So that's going to throw your scale off. So some of you are going to see this is negative, and you want to count that this is going down. 1, 2, 3. Okay, so -3, and you're going to say that's over 2. But watch, if I do my formula, doing the y, so that's 6 minus 2, minus 12, and 4 minus 2. So 6 minus 12, doing the y's, 2 minus y1. Oops, let me go to it, because I forgot to fill in the bottom part. And this was 4 minus 2. Let's see, this came out to be a -3 slope. And if I go back to what I had, minus 2, some of you want to read this as this is a -3 over 2, and that is wrong. Okay, use your formula to get the exact answer each time. Okay, now you could use your list once, especially if they tell you rate of change that has to be linear. And so here's an example here. Go to stat and edit, put in your values of your table, list 1, list 2. Just remember, list 1 is always going to represent the x values, and list 2 is your y values. Okay, then you want to go to stat and arrow over to calculate, and then you want to pick linear regression, and then you hit enter. And in this form, y equals ax plus b is the same thing as y equals mx plus b, and the m is the slope. So I guess to look at the a value, and that would come up with our slope if you want to use that. So that is a possibility. So make sure you can find your rate of change. When you see rate of change, to use your slope, find slope, use your slope formula. That formula is on the formula chart. And then on the next page, there are different forms. Okay, slope intercept form. This is a form you have to, y equals mx plus b, has to be written in this form to use a calculator. Okay, even with decimals, you have to have it in this form, otherwise it's not going to write it or graph it. Your point slope form, this is y minus y1 equals m parentheses x minus x1. We want to use this whenever we're giving a point of the line and the slope. That's why they kind of asterisk that. And then the last one is our standard form, which is ax plus by. So really, the key of all the 3 forms, slope intercept form is the most important. You have to be able to write, and basically you have to be able to go from this form to back to slope intercept or standard. And so this over here is important. These little steps to remember to do. We need you to be able to solve for y. Always add or subtract the opposite sign of the x. We want to get rid of the x term first. So if this is positive, that's what we did. Negative to cancel that. Cancel the 0 pair, then bring down everything carefully. So we bring down the 4y, the equal sign. We rewrite this. We don't add them. These are not like terms. So you write the x term first and then plus 24. So then divide by the number in front of y. That's your coefficient. Divide everything by 4. This -3 over 4 is the fraction. This can be simplified. And now we have it in slope intercept form. And now I can see that's my slope to -3/4. Okay. So here's an example. It's like a word problem telling us where the count began, the balance. Okay. X is the balance of the count. Y is represented by the equation here. There's the what is the rate of change. So that means I'm looking for the slope, which means I'm looking for the m. So basically, I would take this, which is in standard form, change that to slope intercept form. That would require a minus 75x on both sides. So I would get, don't forget that sign, a negative y, it's supposed to be 75x, equals a negative 75x minus 250. We can't have a negative y. Remember what to do when we have that. Exactly, divide by -1. Okay, so we have y equals now a positive 75x plus 250. And because they asked for the slope is your coefficient of x. So it is b, 75 per deposit. Okay. So this is a good example to see if you can get all the parts. So I do want to let you pause the video. I'm going to pause as well, see if you can get to first solving for y, then can you graph it from there? Okay, and let's see if you can find the different parts in here. So just give yourself a pause and let's see if you can get to it. So I'm going to show the steps here. First, we should be subtracting the 2x. That's going to bring everything down. 3y equals a negative 2x minus 6. And then we should divide everything by the number in front of y, the coefficient, which is 3. So the 3 cancels, and now I get y equals a negative 2/3 x minus 2. So we have to remember how to start when graphing this. We always start with the y-intercept. We do this first. Okay. This is where the graph touches the y-axis. So we go down to a negative 2, plot a point. And then we get a different font. This is what we graph second. Okay. This is how we move from this point. We have our pencil on this point. So since our m, I'm going to write over here to the side, is a negative 2/3. That means we're going down 2, and then we're counting to the right 3. If I go down 2, to the right 1, 2, 3, plot point. Now if you ran out of room, because I can still go down to the right 1, 2, 3. But if you ran out of room, you have to go the opposite direction. So up 2, and then to the left, 1, 2, 3. Okay. And so then we're putting a line through those points. Use your straight edge. I'm just going to use this little tool here, kind of line it up. And so now we want to answer the questions about our graph. Our slope was the negative 2/3. The y-intercept is the negative 2, or you can write it as the order pair 0. Please make sure you know that. 0, negative 2. The x-intercept, that's where it touches the x-axis. This is at negative 3, 0. And your 0 is the x-intercept. So it is x equals negative 3. Okay. Your 0, remember, is also known as the solution. Okay. That's our solution. So hopefully you got that. Now we're just taking that in relationship to a real world scenario. And here is another kind of sample STAAR question. The graph is given here, showing the height of a mountain climber and the total number of hours spent climbing. Here's our question. What is the y-intercept of the graph represent? Okay, so y-intercept, I can go up here, there. It's at 300 when it's 0. So this is our initial height of our climber, okay? So we should hopefully pick to B in a scenario like that. All right, so then from rate of change, we're going to ask you to graph and analyze linear inequalities. So when graphing, we still want to graph the y-intercept. Okay, graph y-intercept and use the slope to graph other order pairs. You still want to do that. A couple things you have to remember. When is it dash versus when is it solid? Okay, talking about the inequalities. Also, make sure you know what each inequality means. Okay, so this symbol here, this symbol is like saying less than. Okay, this is less than or equal to. And this is our greater than symbol. Greater, and then greater than or equal to. Okay, so also knowing the symbol, what it means, will help us know when to shade up or above. When it's greater than, we shade above. So this is just an example. You see it's less than, it's a dashed line because there's no line underneath the inequality, and we shade below. So I would definitely memorize what it's supposed to look like for each inequality. Okay, this is very important. What it looks like, where the shading would be. And then this is also important. Remember, your symbol switches when multiplying or dividing by a negative. Okay, so let's go back to some graphing. So in this problem here, they want us to graph this inequality. It's not in slope-intercept form, so we have to put that in slope-intercept form first. So that's the minus 3x. Rewrite everything. So we got negative 2y is greater than negative 3x plus 4. Then we're going to solve for y by dividing everything by negative 2. And because we divided by a negative, we have to remember exactly. Flip the symbol. So this is now less than 3 over 2x minus 2. So we start with the y-intercept, which is, what is our y-intercept? Yeah, negative 2, so put a point there. Then we move using our slope, which is 3 over 2. So we move up 3, 1, 2, 3 to the right 2. Just repeat that. Okay. Ran out of room. I can now go down 3 to the left 2, 1, 2. And because this is just less than, our line is going to be a dash line. And so if I take this off, draw an example right there. Okay. Or you can, if you want to, let me get my pen, you can just add your little dashes in between the points like such. Okay. But because we have this symbol, which is less than, and I'm going to do that in yellow here, less than means we're going to shade below here. Okay, below the line. So there's some things we have to remember with our solution and inequalities. Okay, go back and get that shading. They want us to check if which points are solutions. It's a solution if it's in the shaded or if it's on a solid line. See, this is a dashed line. So if it's on the dashed line, it's not part of the solution. So in this first, they want to say is the point 4, 0. So if I go over 4, can't go up or down. That's this point right here. That's 4, 0. Yes, this is a solution because it's in the shaded. Okay. Now, I do the point 0, 0, which is the origin right there. This would be no, it's not, because it's not in the shaded. Now, they want us to prove algebraically 2, 1 is not a solution. Now, if I basically just graph 2, 1, which is right here, that is on the dotted line. That's not proving algebraically, that's proving graphically. Algebraically means I'm going to put these values, 2 for x, I'm going to put it underneath, 2 for x and 1 for y, into the inequality and check. So the inequality, the original inequality we had was the 3x minus 2y plus minus I is greater than 4. So I'm going to substitute the x, substitute the y, compare it to the 4. So when I plug them in, I'm plugging in the 2 for x, the 1 for y. This becomes, I'm going to rewrite it over here to the side. This becomes 6 minus 2. Is that greater than 4? Well, 6 minus 2 is 4. And 4 is not greater than 4. Okay? 4 is equal to 4. So this would be not a solution. That's showing algebraic. We're doing that algebra in the math. Okay? All right. So now I want you to try this problem. This is very much a STAAR problem, especially with these points here. They tend to like you to click on these points in the shading. This is the graph of 3x minus y. It's shown. That means this is the solid line show. Which points is a solution for the set. So if you need help to see better, I would go still solve for y. Okay. So you can see where the shading is going to be. Okay. So this is what negative y is greater than or equal to negative 3x plus 1. Can't have a negative y. This is again exactly, we're going to divide everything by negative 1. So y is now less than or equal to 3x minus 1. And that matches, there's our minus 1 right here. Rise of 1, 2, 3, run of 1. There we go. But we need to shade, okay? Because our inequality that we're working with is less than, oops, sorry, I'm trying to get that highlighter, is less than, that means we shade below the line, okay? So when they ask, and it's to select 3 points that are solutions, I'll just get my shading done first. Well, the 3 points I should be picking are obviously these 2 points that are in the shaded, but also the point on the line, okay? So a couple things you want to remember is that points on a solid line are part of the solution set. You might want to make a little note of that. I don't know why it's showing see if I can fix this. There we go. So points on a solid line are part of the solution, but dashed line are not. Okay. Sorry about that. Points on dashed line are not. Not. Make that kind of big or not. Not a solution. All right. Okay, make sure you got that done. Sorry about the writing here. Got a delay with my tool. All right, so from here, we're going to go into systems. All right. Remember when graphing, we wanted in mx plus b form. This is very important. Okay. And then we got to remember our types of solutions. Okay. Your solution is the intersection point, and it's a shared order pair. Okay. So, for example, here we got two lines. This is showing one solution. I'm looking for that intersection point. That intersection point is right there at the order pair of -3, 1. There's our solution. Now, if I look at this next pair of lines, this says no solution. And we remember we used an empty set for that. It's no solution because we have parallel lines. Parallel lines never intersect. Okay. And the way that we identify parallel lines is we should see the same slope. And if I look here, there's a visible -1, visible -1. That's why they're parallel. And then infinite many solutions is when we say all real numbers or the infinite sign. And basically what should happen is we have the same line, which means we have the same equation. Now, I see the equation for this first one. The second one, I just need to solve it for y. So I'm just going to move up here, guys. So we had x plus y equals -1. If I solve for y, I'm just subtracting x on both sides. So this will turn into y equals -x minus 1, which is the same equation that I have here. -x minus 1. Same line, same equation. So there's going to always be three types of solutions. Whenever we have a system, you see the word system, look at the graph to find the solution. And remember, there are three types of solution. For my flatness, sorry. Okay, so three types of solutions. And then this is just reminding you how to do this in the calculator, okay? So you put the first equation, make sure it's in y equals to the first one I can do, and then they went ahead and did y2, but we would have to solve this for y by doing, by doing -4x on both sides of the equal sign. Good job. So y equals -4x plus 10, which is what they've already gave us right here. And then it reminds you hit second, trace, and then 5, which is intersection, and enter 3 times. So like I'm just gonna kind of walk through. So here, let me clear this out. We go y1, which was our 5x plus 1, enter. Let me clear this out, and then we had -4x plus 10. We hit graph, so we can see the lines. They have to be visible. The intersection has to be visible in our window for it to work. And then we hit second trace. We pick 5, which is the intersection, and then we hit enter 3 times. And we have to see the word intersection to get to that solution. So we have the intersection at 1, 6, and even in the notes, it's showing the word intersection. So that is our solution to the system. Now, if you do not have a graph, for example, like here on example 3, to come up with the equation for the table, because this, what is the system's equation? This is when I would do L1 and L2 again in stat. So if you go to stat, hit enter. I'm going to clear this out. Oh, I didn't hit clear. Clear, and then come back down, arrow to the left, or to the right, excuse me, arrow up, clear, come back down. All right, so I'm putting in the values for the first table, which we had 0, then 2, then, no, sorry, then 1. So these are increasing by 1. And then I'm going to go to the right, L2, get 7, 6, 5, 4, 3. Okay. All right, so now I want to calculate this equation for this table. So you hit stat again, arrow to the right, we pick 4, which is linear regression, hit enter, and there is my A, my B. So my slope is a -1, my y-intercept is 7, so I'm just going to write that down for this first graph. We have y equals -x plus 7. All right, so I'm going to repeat this, my L1, my L2, for the second table. So I got to go back to my calculator, stat, enter. So I want to change these values in here. So we have 2, and 3, 4, 5, and 6. And then we're going to arrow to the right. Come up here to the top of the list. We had 3, 4, 5, 6, and 7. All right, then we're going to hit stat, arrow to the right to calculate, pick number 4. We're going to enter about 5 times. Now the slope is 1, A is 1, that's our slope, and our B is 1. So this equation, I'm going to write it as, instead of saying 1x, I'm just going to say x. So this is x plus 1. So now that I have both equations, I can, what is the solution to this system? I can do my calculator again, go to y equals, and we had a -x plus 7 here. And then here we had an x plus 1. And we want to graph it. And then I can hit second trace, hit pick number 5, hit enter 3 times. There's my intersection at 3, 4. Okay, that's our solution. So here's a shortcut. So if you have two tables, the solution is where you see the points repeated in both tables. So if I look right here, there is 3, 4, and there is 3, 4. So that would be our solution. It's a point that they share in both tables and on both lines. Okay, so our solution, your answer that you put here is 3, 4. Okay. Now, oops. The other thing besides systems of lines, just of equations, you got to also know your inequalities. So make sure, again, you know your symbols. Okay. The solution, we have 2 inequalities, is when it overlaps. This is when I tend to write a big capital S to show the solution. And also, it should be darker when you shade it. Okay. So the first thing is we want to be able to write the equation for each line. Okay. So this solid blue line on me, or your solid line, I'm going to make that L1. And to write the equation for L1, what I first want to be able to do is see where is the shading. Okay, the shading is above that line, so that's going to be greater than. Then I want to look at the type of line. It's solid, so it's greater than or equal to. So now I want to find the y-intercept. Right here is at 2, and I want to find the slope. If I look to go to the next point, this is down 1, to the right 1. I can see this is slope of a -1. So this is -x plus 2. All right, so then my dotted line here, this is my L2. Okay, L2 is a dotted line, and it's also shaded below. So this is y is less than. I know it looks kind of off, but my y-intercept is right here at a -3. And I'm looking at a slope of going up 1 to the right 2. It's positive because it's increased. So, oops, I wrote that 3. Sorry. This is 1 over 2x minus 3. And there is our two inequalities. So sometimes you have to come up with inequality from the graph. And then sometimes if you look at 21 and 22, we just want you to graph them. So we practice one line. Let's see if you can just practice shading for 2. Okay. So I'm going to start with this first inequality as my red line. We start at positive 4. It's a slope of 3. I can't go up 3. So I'm going to go down 3, 1, 2, 3, and then to the left 1. Okay, and then we're going to make a line for these points, such, and we're going to shade it. So because we have less than and equal to, this shading should be below the line, like such. Okay, doesn't have to fill it up, just kind of get the idea. Okay, now for the second inequality, it's not in slope-intercept form. So to do that, I'm going to have to minus the 2x. And now I see it. Y is less than negative 2x minus 1. So y-intercept is negative 1. Slope's negative 2, so that's down 2 to the right 1. Remember, the line should be decreasing or going up 2 to the left 1. And I can now see where the lines cross. So I'm just going to go ahead and extend that right there. Make this a little bit accurate. And because it's less than, I'm shading below the line. And I can, hopefully you can see the shading below would overlap here. That's what we're looking for. We're looking for when they overlap. So that would be our solution right there. So now we're checking. Or did it give us, oh, it didn't give us one. Oh, is 1, 5. There it goes. It did ask us to check. Is the point negative 1, positive 5 up here a solution? And that would be no. Okay. Negative 1, 5 is not a solution. This is not in the overlapping shaded. Now, if you look here, we're going to get no solution. You just got to remember what that looks like. So greater than or equal to, there's that solid line. If it's greater, it's shaded above the line. So that would be here. This is less than, that's the dotted line. If it's less than, it's shaded below. Oops, I meant to do that in a different color, sorry. It's shaded, fix that. It's shaded below the line, like that. So a no solution, obviously you can see it now. A no solution is when there's no overlapping. Oops, where's my shaded? There it is. No overlapping. So I'm just going to write in this section right here, this is our no solution. Very good. This basically means we have no overlapping shaded. Shaded region. The shaded section. No overlapping. Okay. All right, well that takes care of, wait. Oh yeah, transformations, forgot. On here, there's some words you want to, the best thing is you want to look at the two graphs to compare. So whenever I see this word transform, look at two graphs and compare. So this is just kind of some recaps. If I see vertical translation, this is meaning going up or down. The adding or subtracting would be outside the parentheses. Horizontal, so vertical is going up, that's positive. Down, that's subtraction. Positive is addition, I mean. Horizontal translation, that's left and right. If I'm going left, that's actually positive. If I'm going right, that's actually subtraction. Okay. Dilation, a vertical stretch is when this number in front of the, or your slope is greater than 1. And a horizontal stretch is when, or compression, horizontal shrink or compression. So steeper, if it's a stretch, it's deeper, narrower, okay, flatter. This is when our number here is inside the parentheses, number 1, and it's between 0 and 1. It's a fraction or a decimal. And then anytime I see a negative, it's reflecting over the x-axis. that's inside, and then if it's inside, it's reflecting over the y. Okay, so this is why I said it's easy to compare. So I would write this as y equals x, and then y2 equals 3x minus 2. Okay, and then compare them. But I'm going to show you, let me put, there's y, let's put both of these in here. So y equals x, that's your parent function for linear. And then we have, it was what, 3x minus 2. So 3x minus 2. And then we're graphing, and we're trying to compare. So hopefully, if I go back, you'll see it if you didn't understand the parts. This original was our parent. Okay. And then our new right there, that tells me something that's going to be stretch or become steeper. So because it's greater than 1, right there, we have a stretch. And then we have minus outside the parentheses. This is a vertical. Okay. Because we have this minus, that means we're going down. Oh, I'm just going to try. It means we're going down 2. Okay. It's indicating down 2 units. Okay. So the stretch means it's steeper than the parent, and I can look at the graph and see that. Okay, this is the parent, the blue, and then the red is going up faster, so it has a steeper graph. And the thing I wanted to talk about is, let's say you're not too sure how to rewrite it. Okay, because a lot of people get confused on how to rewrite it from f of x to g sub x with this f of x in there. If you use this is one thing where the Desmos calculator might be more beneficial. Hold on, let me show you. All right, this might be more beneficial because you can type it like you see it, f parentheses x equals x. Enter, there it is. And then you can go g parentheses x, close the parentheses, and then type how I saw it. It was 3, then the f, oops, sorry, then the parentheses x, and then we had minus 2. And then I can physically see that it got steeper and it shifts to the right. No, shift down to, right here, shift down to, okay? So that, just, try to use whatever calculator you feel most comfortable with, but kind of messing with both kind of helps you. So hopefully we see on this one, this negative sign, oops, right here, means we're going to get a reflection. I'm just going to abbreviate that over the x-axis. And then the other thing I see is this +2 inside, means I'm going to do a horizontal shift to the left. Okay. So it's our left 2 units. Parent, and looks right here. So this is when it's inside the parentheses. This kind of goes with this one, AX. This is a horizontal stretch. No, shrink, because it's greater than 1, sorry. Forgot, 3 is greater than 1. So right here, horizontal shrink, or they call that a compression. And then our last thing, this is the part, we had a lot of questions on this, because you have some of these on your practice. Just understand, association does not imply causation. Okay, causation is just really cause and effect. Okay, 2 variables that do not have a cause and effect. Association, causation, 2 variables, what they cause and effect. And then they gave you some examples. So there's not really math here. You just got to understand cause and effect. Like one thing affects the other. Okay. The number of floors in the building does depend on the height, right, of each floor. As you get the number of weight you gain does depend on, or is a cause of the number of calories consumed. Okay, so there's just an example there, and that takes care of RC2. We're going to move into RC3. So RC2 and 3 is where most of your questions are going to be. So there's a lot, I guess, in these 2 sections. All right, thanks.